Okay, so today's lesson is 4-7, the real number system. So what I want you to do is here, you're going to copy down this entire little box that says real numbers. You're not coloring, but you're going to have a circle with integers, whole numbers, natural numbers, rational numbers, and irrational over here. So draw this little table. You can pause the video to do that now. Okay, so now we're going to talk about it. We have in the very center, this green one is natural numbers. So that's kind of like your counting numbers. We start with 1, 2, 3, and so on. We don't start counting with 0, and we don't use negatives. We just start with 1. So 1, 2, 3, and so on. Well, then when you get to whole numbers, it's those same numbers we just talked about that you count by and 0. That's the only difference. So that's why this natural numbers is inside the whole number circle. This is actually a Venn diagram. It's just not like the ones you're used to seeing. We're used to seeing the ones that are two circles like this. And everything that's in both of them is right there. Well, in this, everything that's in both of these is just inside this green circle. Okay, so then outside the yellow circle, we have a blue circle of integers. So integers are all the numbers we just talked about, these numbers and 0, and now negative numbers. Okay, so then the only other one those are inside of is this square that's rational numbers. So rational numbers basically just means any number that can be written as a fraction. So whole numbers, like for example, the whole number 5, it can be written as a fraction by just putting it over 1. That's a fraction and it still means 5. So it's all our natural numbers, our whole numbers, and our integers, because we could have negative 1 over 2. Okay, it's still a fraction and it's negative. So for example, they have like 0.45 here because that can still be written as a fraction. Actually, if we read that correctly, that means 45 hundredths. Well, that means 45 over 100. 45 hundredths. That's what that means. So, rational numbers are any number that can be written as a fraction. So then we have this one over here that's all by itself. Okay, irrational numbers. We don't have too many of those. Irrational numbers are numbers that cannot be written as a fraction. So, for example, the square root of 3, because it comes out to a long decimal that's never ending and it's not repeating. Back over here, this repeating decimal, that can be a fraction, 0.4444 and so on. But like this number, 1.21231234, there's no pattern and it goes on forever. So there's no way to write that as a fraction. And the number pi is actually irrational because it's a never-ending number as well. So when we're looking at this, most of what we're going to deal with today is in the rational numbers. Okay, all of these. I'm going to show you on the board another type of Venn diagram to help you understand kind of how this works with a circle inside another circle. Okay, I'll try and explain that a little bit better using something else. All right, guys, so this diagram, say this center circle is your class, whether it's second hour, third hour, sixth hour, or seventh hour. I'm going to say second hour. Okay, so then this circle that it's inside, that would be 8th grade. Because you can be in 8th grade and you can be in my second class, but you could be in 8th grade and not be in my second hour. But if you're in second hour, you're also in the 8th grade. Okay, so then this even bigger circle would be the middle school. Okay, because you could be in 6th grade and be in here, but not be in the 8th grade or my second hour. Okay, so it doesn't go backwards, but if you're in the inside circle, you're in everything. It goes out. Okay, and then out here it could be the high school because it's not in any of it. Okay, so that's kind of how the Venn diagram. Looking at this first example where it says name all sets of numbers to which each real number belongs, right? Natural, whole, integer, rational, or irrational. So on all 4 of these, the first one, we have 21 over 7. Well, 21 divided by 7 equals 3. Okay, so 3 is a natural number because we count 1, 2, 3. It's a whole number, It's an integer because integers, are all your positive and negative whole numbers. And it's a rational number because 3 can be written as a fraction, 3 over 1, even though it started out 21 over 7. So rather than having to write these whole words, you can write just the capital letters, N for natural number, W if it's a whole number, I if it's an integer, R if it's rational, and for irrational, you can write it. You can write out irrational. So this first one ended up being all 4 of those. So we would have to write all 4 of those down because it's in that inner circle. If it's in that inner circle, it's in all of them. So negative 2.5. So that is not a whole number because it's a decimal. If it's a decimal, it's not natural, it's not a whole number, and it's not an integer. But first, you got to see if it can be written as a fraction. To do that, to write it as a fraction, I would say that is 5 over 10 because that's the 5 tenths. That's the tenth place value. So negative 2 and 5 tenths, that can be written as a fraction. So that would be a rational number. That would only be R. Okay, on C, we have 0.2 repeating. That line means repeating. Okay, so again, it's a decimal, so we know it's not natural, whole number, or integer, so it's either going to be just rational or it's irrational. And if we look, that can actually be written as a fraction. Most repeating decimals can, as 2 over 9. So that one is also just R. Okay, then on D, we have the square root of 38. If you plug that in your calculator, you can see you get like 6.164 and some random stuff. So there's no way to write that as a fraction. It does not have a perfect square root. So that is the only one that's irrational on this list. Like I told you, you're not going to have many that are irrational. Most of them fall in the rational side. So I want you to try 1A and 1B. Don't worry about the other two. And pause the video so you can try them on your own, and then I'll work them out with you. Okay, on these first 2 examples, you were just having to tell me which part of the Venn diagram it would fall in, and you list all that it applies to. So 0.7, that's not a whole number, so it's not a natural number, it's not positive or a negative whole number, but it is a decimal, so we have to see if we can write it as a fraction. Well, if you read that decimal, that is 7 tenths, because that's in the tenths place. So it is a fraction. So that would be a rational number. And if you just write R, that's fine. Okay? So the next one we have is the square root of 100. So go ahead and solve that. The square root of 100 is 10. So if we look at all that applies to, okay, that's a number we count by. So it's a natural number. So you just put an N. It's a whole number. So it's an integer, positive or negative. So therefore, it's a rational number. We could write that as a fraction by putting it over 1. Okay, so it's in all 4 of them. Let's look at example 2. So now we're going to be comparing. We have less than, greater than, or equal to make 3 and 1 over 3 compared to the square root of 15 a true statement. So what we want to do is change them both to decimals. So 3 is a whole number, so you just have to change 1/3 to a decimal. When you do that, it is a 3 repeating. So 3 and 1 over 3 is 3.333, and so on. So then square root of 15, if you plug that into your calculator, you get 3.87298334, and so on. So when we're comparing these, we look, okay, well, they both have 3 for a whole number. So we look at the first number behind the decimal. I have an 8 and a 3, so 8 is bigger. So that means the square root of 15 is bigger. So we put a less than symbol because 3 and 1/3 is less than the square root of 15. So you're going to try number 2. 7 and 2 over 5 compared to the square root of 57. So you'll either put less than, greater than, or equal to make that a true statement. Okay guys, so we are comparing 3 and 1/3 to the square root of 15. We're replacing with the less than, greater than, or equal to sign to make it true. So we first have to change them to decimals. 3 and 1/3, that is a repeating decimal. The 3 is repeating. Okay, I'm just going to put 3 of them so far. So then in your calculator, if you do the square root, sorry I typed the wrong of 15. It is 3.872 and some other random numbers. So what we do, they both have the same whole number, so we have to look behind the decimal. This one has an 8 and this one has a 3. 8 is bigger, so the square root of 15 is bigger. So it should be 3 1/3 is less than the square root of 15. Okay, so I realized the problem I worked out on the board was the wrong one. Sorry about that. So 7 2 over 5. If you change that to a decimal, 7's already a whole number, so 2 over 5 is exactly 0.4. So we have 7.4. And then the square root of 57, if you plug that in your calculator, it's 7.5498 and so on. So if we look, they both have a 7, so we look right behind it, 5 and 4. 5 is bigger, so the square root of 57 is bigger. So it should be a less than symbol between them. Okay, so now looking at example 3. We're going to order the set. We have 8 and 4 over 5, the square root of 64, 8.3 repeating, that's what that line means above that, and the square root of 76 from least to greatest. So we're going to do smallest to biggest on this. So the first thing we do is change them all to a decimal. So 8 and 4/5 is 8.8. The square root of 64 is exactly 8. 8.3 repeating just means that 3 goes on and on and on. And the square root of 76 is 8.7177978, and so on. So to put them in order, they all have an 8 out front. So we look behind the decimal. If they don't have one, you can add a 0 to see how they compare. So we have 8, 0, 3, and 7. So since this is least to greatest, the smallest would be that 0, which is the square root of 64. You have to put them back in their original form. So what I do is once I get one in the order, I mark it out. So next I have 8, 3, and 7. The next smallest number is 3. So 8.3 repeating would be next. So I can mark that out. So then I have 7 and 8. So 7 would be next. So the square root of 76. And then the biggest one with an 8 is 8 and 4/5. So we go back and put them in order. Don't forget they have to be in their original form or I won't accept it. So I want you to try problem number 3. I know these take a little more time. You're going to put these in order. The square root of 30, 5.6, 15 over 3, and 5 2/3. This time from greatest to least. Okay, on the next problem, we are putting these numbers in order from greatest to least. I have the square root of 30, 5.6, 15 over 3, and 5 2/3. We're going to put them all in decimals in order to compare them. So this one's already a decimal, and I'm going to line them up. So the square root of 30, if you plug that into your calculator, we get 5.4772. I'm just going to put 4 numbers for now. 3 or 4 is good. This one is 5.6. So for all the missing spots, I'll just put zeros. 15 divided by 3, we know is exactly 5. So these would all be zeros. And then 5 2/3. 2/3 is a repeating decimal. If you plug 2 divided by 3 into your calculator, that is 0.6 repeating. Okay, so now to compare them. The first part, they all have the same whole number. Okay, we're looking for the greatest. So we look behind it. I have a 4, 6, 0, and 6. So for the greatest, it's only between these two. So I move over to the next. I have a 0 and a 6. So this is the biggest one. So you go back and put it in its original form because that was 5 2/3. So the next biggest one is this that was next, 5.6. I like to mark them out once I'm done so I don't get confused. So now we're back to these two. I have a 0 and a 4. So 4 would be next. That was the square root of 30. And then our last one was 15 over 3. So that is in the correct order from greatest to least. Make sure you pay attention to that because on your homework it might be least to greatest. So we have 5 2/3, 5.6, square root of 30, and 15 over 3. Okay, so the last problems that we'll look at today, we have solve each equation and round to the nearest tenth if necessary. Okay, so what this means, we're going to be solving for a variable, normally x, but in this case, a. So this says a to the second power equals 38, or a squared equals 38. So we got to get a by itself, so we have to get rid of this exponent. So to do that, since it's squared or to the second power, the opposite of that is to take the square root of both sides of the equation. So the square root of a squared, well, the squared and the square root cancel, and you just have a. So then what that means, we take the square root of 38 because we do it on both sides. When we do that, we get about 6.2 because it goes on and on, so you have to round on that one. So we use that little squiggle that I've talked about, approximately 6.2. Okay, so then on B, if you notice on here, they tell you need the positive and negative because we've talked about square root. There could be a positive and negative version. Then on this problem, we have a to the third power. So, excuse me, we have to, that is the cubed, a cubed, so we have to take the cube root on this problem, okay, from both sides of the equal sign. That's hard to tell that that's a little 3, but the cube root. So now, when we do that, the cube root of 125 is 5. So the solution would be a equals 5. I do want to mention if there had been a number out front, like let's say, hold on, let me plug a number in my calculator that works. I guess it really doesn't matter if it works or not. Let's say we have this problem, 2a squared equals, let's see, 76. If we have this and we're solving for a, we have to get rid of this 2 that's being multiplied and the exponent. We have to get rid of the one that's being multiplied first. And we do the opposite and divide both sides by 2. 2 divided by 2 is 1, so I'm left with a squared, or to the second power. 76 divided by 2 is 38. Now, at this point, it kind of turns back into this problem. We get rid of that second power by doing the opposite, just like we did up here. The opposite of multiplying was dividing. The opposite of a number to the second power is the square root. And then that still gives us approximately 6.2. So what I want you to do, you're going to do 4A and 4D. I'm not going to make you do all 4 of these. You're just going to do 2 of them. So pause the video, try those, and then I'll go over them for you. Okay, 4A and 4D. 4A says 363 equals 3D squared. So we're solving for D. So here's D, here's the equal sign. So I've got to get rid of the squared and the 3. The 3 is just being multiplied, so I'm going to get rid of it first. So that means I'm going to divide both sides of this equal sign by 3, because we have to keep it balanced. So you do the same thing on both sides. So 363 divided by 3 is 121 equals 3 divided by 3 is 1. And we want that. 1 times d squared is just d squared. So we're close. Now I have to get rid of that second power, or the squared, d squared. So the opposite of squaring a number, or raising it to the second power, is to take the square root. So I'm going to take the square root of both sides, and it cancels that squared to leave me d. So the square root of 121 is 11. So the correct answer on that is d equals 11. Even though it says 11 equals d, that means the same thing. If you want to go back and flip it, that's fine too. Okay, on D, we have 512 equals x cubed. Now it's to the third power. So to do the opposite, because that's all I have to get rid of to solve for x, there's nothing else to do first, I have to take the cube root of both sides. Not the square root, the cube root. That's what will cancel that. So if we do the cube root of 151, 151, listen to me. The cube root of 512, we get 8. X equals 8.